Hi there, welcome to another episode of Shed Manufacturing, and in today's installment we'll be trying to build a downpipe for the project Turbo E30. What we have is a bunch of pie cuts of stainless steel, and from there we'll be converting them into, instead of little slivers of steel, a nice long tube that'll go from the turbo down to the rest of the exhaust that we haven't made yet, but we'll get to that. So yeah, follow along, I think it should be a good time. So while I'm getting all of these pieces all cleaned up and ready for their initial tack up, I figured we could have a quick chat about design considerations, material choice, and tubing diameters. So this is a fairly low boost and low power objective car. I only really want between 250 to 350 at the absolute maximum at the rear tires. 350 would sort of just be a cold weather party tune only. I'm really uninterested in making a car that's sort of unbalanced. I really like the BMW chassis and how well balanced it is. My only gripe is that it just doesn't quite have the beans to make it really, really enjoyable on 1/3 of the corners, which is exit. Corner entry and mid corner, fantastic, but it just doesn't quite have the beans to make it truly exciting on the way out. I estimate that about another 70 to 100 horse will do that really, really well, which would put us right around the 270-ish mark. But anyway, I'm getting off topic here. The turbo I have is really a decent little bit bigger than what I will need for my power goals. But I wanted the turbo of that size, so that way it would have nice low intake air temperatures for the size of intercooler that I'm going to run. It's also going to be more laggy, which I'm not thrilled about, which is why I made sure it was a twin scroll turbine housing, and I got a twin scroll manifold to go with it. Those have both been known to really, really improve on throttle turbo lag, and really across the dyno graph, you pick up power sort of everywhere with those. But one of the parts of the equation of making good power out of any turbine system is getting the exhaust gases out the way. So for the majority of the exhaust, we'll be using this 2.5, but for the downpipe, we'll be stepping up to this 3-inch tubing. The idea, and it's pretty data backed, is that if you have your exhaust gases right out of the turbine wheel of the turbo, go into a larger downpipe, they slow down, they have a much lower velocity. And with that lower velocity, it creates less back pressure in the manifold, less back pressure on the turbine, allows the turbo to spool quicker. But you don't need that large diameter pipe the entire way, because as the exhaust gas goes down in the tube, it actually cools down and shrinks. So a smaller diameter pipe can flow the same amount of horsepower further down in the exhaust system. Now this is only really true for the first couple feet of the exhaust system. Once you get towards the middle and the back of the car, it's all sort of much of a muchness. It doesn't cool down appreciably for you to get any gains from smaller pipes further down. But you certainly can get away with a smaller exhaust system and reap the benefits of a larger one with just the addition of a downpipe. So that's what we're striving for. So I decided to settle on 304 stainless steel tubing. And to be honest with you, I really don't like stainless steel. I don't like working with it. I don't like its material properties for the majority of the time. The only thing that it's really good at is not rusting. But it's heavier than regular steel, which I don't like. It's much harder to cut than regular steel, which I don't like. If you're tapping threads into it or machining it on a mill, it galls. It's just it's not a great material to actually work with, but my goodness, does it not rust. Which in a high temperature environment, like an exhaust system, where you have the pores of the metal opened up by temperature and then cooled down rapidly, is kind of a big deal. Like you'll introduce rust into a system much faster in an exhaust than you will in pretty much any other circumstance. All right then, let's get some of these fitted up. We're just about done here. Alright, so I have you on the handheld so I can get you under the car and show you what we've been getting accomplished today. So the reason the pipe's so funny shaped is because it has to snake around quite a lot of equipment. So as we look up, this is the underside of the turbo manifold and the turbo. Sorry, I'll try and get that, shine up the camera for you. And the downpipe has to come straight off the back, miss the firewall, which we can probably just about see from right there, and then come down and then snake around this lower control arm mount and not hit the transmission. And I want to do all of this while staying nice and tucked up. So if I come back from the car and put us in the transmission tunnel, you can barely see that pipe up there. So we've stayed nice and tucked up, so when I inevitably drive over something big, it won't smash it to bits and inhibit our flow. This is all done with pie cuts and 304 stainless. So this is sort of my first venture into a big stainless project. So the next up is we'll be adding the reducer shown right here and the bellows, and what that will do is that'll get us back to 2.5, and we'll have a V-band welded to the end of that bellows, so the downpipe will be able to expand and contract a little bit without putting strain on anything else, and we will also support it probably on this factory bracket, although I will probably modify it. I'll probably relocate this upper hole right here to then be able to bring this bracket up just a bit to get these two bolts out of harm's way. I also might shave it down a bit, and then on this side, this is almost certainly going to get bent probably right here through 90 degrees away from the camera, so that way obviously it looks like it's not going to fit at all with the 3-inch pipe, but the 2.5 is enough of a reduction, and we put the reducer on the bellows at about a 9-degree angle, so we should be dead nut straight coming back from here, and the reduced pipe diameter should clear all of the other bits and pieces through there. But it's getting a bit late, so it's time for me to pop to bed. Well, here we are at sort of the rubber meets the road point in this. I can't continue to build the exhaust until I really know where this is going to lie. Now I know you've seen some of the rest of the exhaust past the downpipe get made, but before I burn that in, I want to make sure this gets fully seam welded. The reason behind that is because stainless is known for moving around when you weld it. So although it'll stay more or less this shape, some of the corners will be a little tighter, some will be a little looser, and I want to make sure that all of that is taken into account before we go ahead, tack the entire exhaust up, get the whole thing made, and go to put it in the car, only to find out it doesn't fit. So right now we're just going to get the downpipe cleaned off for the last time. I did mark where the fuck is this thing? I did mark where the wideband oxygen sensor was going to go. I went ahead and drilled that hole and got it sitting nicely in there. I also ran the wideband through the center console of the car, through a factory drain plug, made a new grommet, made a new drain, so that way I can have a nice serviceable oxygen sensor that has all of its wiring retained inside the car away from the elements. So we're going to get that burned in, fully welded, and I have the trusty tin foil for filling the ends. We'll be using the MIG welder's gas port to poke in the end, although to be honest I'll probably stick it in there with a little bit of tin foil, and that will get us to back purge, and then we'll be able to weld this fully. All right, here we go. Downpipe's all in, getting the V-band all tightened up and all squared away. Everything looks pretty Gucci. Time to get the back set up into its little home. Got that in there. And time to get the front up into the little mount that I made. And Now what we just saw is the textbook reason as to why you make these sorts of things, these pie cut downpipes, in a jig. Something that I didn't do. So what happened during the welding process is this joint, I suspect, shrunk. This one seems to be pretty much where we left it. All the clearances from turbo down to firewall, happy as a clam. But when it kicks up from the firewall and goes to the collector at the rear that's right next to the transmission that goes to the rest of the exhaust, we are a good little bit raised up from where we were when we set everything and tacked it. So we have a couple of options. One, scrap it, or option two, which I much prefer, which is where we stretch it. Now I know the pipe stretcher is something that usually the foreman tells you to go find on your first day of work, but I've repurposed an engine crane to make one. So I'll take a couple measurements from probably this weld right here to the tip of this flange, put some tons on her, and we'll see what happens. Well, after thinking about what I was actually doing for really more than a couple of minutes, I came to the conclusion that the put it in a engine hoist and stretch it until it does what I want it to method probably wasn't the wisest. With my poor quality welding and the unknown origin of some of this stainless material, I figured I was more likely to just break it or kink it than I was to actually get it to bend in the way that I wanted to. So I'm going to do what I should have done from the beginning and cut one of these welds. So I suspect this area here in this part of the pipe is what is causing it to tighten up. Right there we have some very close, very short radius pie cuts, which put a lot of heat into one small area, and I suspect that's primarily what caused this end to kick up high into the chassis. So I could remedy it here, but I think I'll get the most bang for my buck if I cut the back side of this weld, close the gap, which will be the kerf of the angle grinder blade, and re-weld this, and then see what we got. If not, I'll do it again on this side, and again, we'll see what we got. And we'll sort of chase it around that way, actually cutting and welding and having it sit where we want it to, instead of, you know, just trying to stretch it and hope for the best. So yeah, let's see what this does. Okay, if any of this is going to be realistic data that I can pull, I have to make a little bit of a jig so I can determine if the cuts that I've made have actually resulted in any change at the big end. So what we have is a very rudimentary jig. I have this clamp holding a vise onto the table, and we will square one of the tubes that we won't be messing with up onto it, with the reference being our first weld of the main neck down, and then we have a mag clamp on the table that's just touching where it is now. So we're looking for about half an inch or so of movement. So we'll get to chopping and see what we got. So here we are back under the car, and with a single heat of the moment, unback purged and fairly sloppy weld done, the downpipe fits much better. As we can see, it's mating up nicely to the rest of the exhaust that we have tacked up and gotten ready. It's back to pretty much its original position. And that's something that I can absolutely live with. It's a little bit further that way in the chassis, a little bit further forward, so I'll have to modify the mount right here for where the pickup of the OEM bracket for the exhaust stabilizer goes. And that'll be either moving a combination of the bracket itself, or it'll be cutting off the bracket on the exhaust side and moving that a little bit up the tube. But as you can see, both the mating flanges fit perfectly well for the movement that the bellows affords us. So I'd consider this a win. Time to move on to getting the wastegate installed and the wastegate routing done, and then the oil cooler, and then get the rest of this welded up, and then obviously I have to make the coupler for the back, and then we have to set the computer to deal with the new wasted spark system. And anyway,